Alright, so we're going to talk about chapter number 4. So chapter number 4 is a pretty big chapter, but I'm hoping that most of you remember a little bit of it from 505. It's not then not, but it should be a refresher, but it's again more advanced level of what you have seen in 505. So you can read through the first page. What are some of the key concepts and skills that you're going to learn? Here is the outline, and again, remember this. Most of the other subsequent chapter, like the valuation of stocks, the valuation of bond, and the net present value, and the capital budgeting decision chapter, they're all kind of tied to the chapter. In other words, you need to know the tools that you learn from this chapter to be able to apply to subsequent chapters, right? A lot of subsequent chapters. So make sure you're taking notes. Make sure you have 6 or 7 days. You study well. Read through my lecture notes, the book, work on the calculator again. I will spend 5 or 10 minutes on the calculator. I'll also make a little video on the calculator so that I can use it later. All right, DCF wise study to make basic investment decision for ourselves. All right, let's suppose you invest some money in a savings account and you would like to know how much would your money grow to or accumulate to in 4 years or 5 years or 9 years or 10 years. Planning to retire, how much do you need to set aside each year in order to have $10 million by the time you're 45? Trying to buy a house or a car, how much do you need to save today in order to buy it? You win a lottery, how much would you be willing to accept if you were given a choice between a lump sum money now or some regular stream of cash flows each year, each quarter? All right, just like us, financial managers also need to know whether or not investment is worth it, and they also need to know whether they're making enough cash flows to satisfy future shareholders. All right. So let's look at some terminologies and let's get familiar with a couple of notations. First of all, what is the concept behind time value of money? All right, time value of money refers to the fact that a dollar or X amount of money, it doesn't have to be a dollar, it could be any sum of money out there, is worth more today than a dollar anytime in the future. Well, why is that? And the book talks about the same reasons that I talk about. Well, first of all, you can take that money, or $1, $100, $1,000, $10,000, put it in a bank at a savings account and earn more than that dollar or $10,000 or $1,000. All right. With that dollar, you can gratify your immediate needs. All right. So let's say you have a dollar, you can go to either Taco Bell or I don't know, McDonald's and get satisfy or gratify your needs, or go to I don't know, the dollar store and buy some a very useful item that we will use forever, or again, it's going to gratify your immediate need. Everybody likes instant gratification. Last but not least, well, we are all affected by inflation. Remember, inflation, normally, historically, inflation has gone up. Even if you compare your grocery bill now to what it was 10 years ago, you would be like, oh my God, are you serious? Milk prices have gone up, bread prices have gone up, grocery bills in general have gone up a lot. So that dollar that you receive today will probably not be able to buy you the same basket of goods anytime in the future. Okay? So let's get a little familiar with the notation that I'm hoping you've already seen. We have a timeline. All right, so a timeline is nothing but dollar received or dollar paid. It just is a little graph or a little timeline that shows a diagram that shows you either cash inflow or cash outflow. So in this timeline, we have $100 cash outflow, $200 cash outflow, $300 cash outflow, inflow. So $100 inflow, $200 inflow, and $300 inflow. And outflow would be indicated by a negative sign. So if you had 800, 200, 300. I'm sure you remember what present value and future value are, but just to refresh your memory, present value is the value of an investment now, time period 0, or in current terms, current dollar amount. So what is the present value? What is the market value of your house now? Let's say it's $463,000. That's the again present value. What's the present value of any assets at the price as of time period 0? Future value, on the other hand, is forward-looking. That means you're trying to find the value of something 1, 2, 3, 4 n years into the future. Let's look at some notations. Now we have PV, present value, and PV, future value. N or T is the number of years, RI is the interest rate, and cash flow is the cash flow. All right. So remember these notations. You'll see them, time and again, and you might have seen them, you might have forgotten about them, but again, a refresher. All right. Now in chapter number 4, the book distinguishes between what is simple interest versus what is compound interest. And all the problems we will be doing, most of them, unless I tell you it's a simple interest problem, we will assume that the interest is compounded. Does anybody remember simple versus compounded, and what is the implication of simple versus compounded? Let's see. What is simple interest? Do you want to give it a shot? All right, I'll just explain it to you if you don't want to. Well, in simple interest, we're assuming that we're earning interest on the principal value or the original value only. So we have an example here, interest earned at 6% for 5 years on $100. So if you look at the example that I have in front of you, you see that each year we're only earning $6. We're earning $6, $6, $6 because we are earning interest on the $100, right? 6% on $100. So if you want to know how much did we make in 5 years, we see that, well, we made $30, which was in interest, and then we had the original $100. We add them together, and we have $130. Yes or no? Very straightforward, very simple, and rudimentary, and something that you have seen, I'm sure, before. All right, so that's simple interest again. The assumption that we are only going to earn interest on the original principal, $100. All right, however, it's not very realistic in the sense that all the problems we'll be doing is based on the assumption that interest is compounded. All right, so what about compound interest? So we have an same example now. $100, 5 years, 6%. And we see that, well, the first year, it doesn't make a difference. We're still getting $6. But we notice the difference from the second year. All right, so in the second year, instead of $6, we have $6.36. Third year, we have $6.74, and so on and so forth. So what is essentially happening here? Why are we seeing the numbers other than $6? Anybody?
Interest on the interest.
All right, exactly. So we are earning interest on top of the interest. So in year 1, 106. In year 2, we're earning interest on 106. Year 3 on whatever that was, and so on and so forth. So, in the first example, in simple interest, we ended up with $130. Now we ended up with $133.82. But again, that number or the cumulative effect depends on a lot of factors, like what was the original principal, what was the interest rate, how long are we holding the investment for. So yeah, we would appreciate it if you were, let's say, looking at $1 million at 10% for 20 years versus simple versus compound. Okay? So if you don't remember, just refresh your memory again. We're going to be dealing with compounding. Okay? The first formula that you need to know is the future value formula. Again, we tried to calculate what the future value is. What would $100 be in 5 years at 5%, right? Or 6%, right? So we don't need to do an iterative, one at a time, 1 year at a time. We can easily plug it into your calculator. So we have future value, and I'm going to write it down on the board. Future value, and you know what, I'll open this, and I'm also going to write a couple of other things. The first couple of formulas that we need to know about is the following. The first one is future value equal present value times 1 plus I raised to the n, and present value therefore equal future value divided by 1 plus I raised to the n. So if you just remember one, the other one is just an changing order and algebraic manipulation of the other one, just changing the order. All right, so that's the formula for future value and present value. So in our example, we would have equal. It was $100 at 6%, right? Mm-hmm. 0.06 raised to the 5. Right? If we wanted to use our financial calculator, all right, so let's say we want to use our financial calculator that you promised you're gonna, on the way home tonight, you're gonna buy. Now this is what you're gonna do. 100 is your PV. Alright. 6 is your I by Y. 5 is your N. And this is fine calc. Alright. And compute future value. Right? So 100 is your PV. So the calculator works this way. I'll just tell you. Number and then function. Alright, so you do 100 PV, saying that $100 is the present value. 6 is the I by Y. Calculator already knows that this is 6% because it's a financial calculator. But if you put 0.06, it thinks it's 0.06%. So you're not going to put any decimals if you're using the financial calc like I did over there. Does that make sense? Yes. 5M, and then there's a CPT button. CPT button says compute, right? So compute future value. And you would have something very, very close to $133 and some odd cents, okay? So that's using financial calculator. As you can see, it's pretty easy, pretty simple. All you have to do is, I know what am I solving for? Again, one word of warning about the calculator. Remember, I follow what's known as the GIGO model. All right, it's very important. It's a state-of-the-art model. And I don't know if I can explain it well to you or not, but I'll try. All right, so GIGO stands for garbage in and garbage out. Okay? So you have your calculator. It has buttons, and you punch in stuff. It'll spit out something, but make sure that it's not garbage in, garbage out. Now, this is the most basic form of problem. As we progress, we'll see that the problems are getting quite advanced. And make sure that you read it, understand it, and then plug it in your calculator rather than just plugging stuff in that doesn't make any sense. Okay. So this is again the most basic form that you have seen. I'm pretty sure. All right. This is how you calculate future value. Does anybody need to write anything more?
I have a quick question.
Sure.
I haven't used a financial calculator in years, but isn't the N? I thought it was months, so wouldn't it be 60? Or am I?
Well, we will talk about non-annual compounding, but right now the assumption is that everything is annual.
Okay.
So this is a good question, though. All right. So all right, let's go back. Good question, though. And that's the future value. Hopefully we've all heard of it. If you don't remember it, let's remember it. Here are some notes about the calculator, since most of you don't have it. But when I have important notes about the calculator formatted, it's also in that handout. You have to format it. Okay. Let's look at present value now. As I just told you, it's just the opposite of the future value. It says how much should be set aside today in order to get some payoff in the near or distant future. And that's the formula for present value for only 1 year. But if you want to do a problem like this, and suppose you need $10,000 in 3 years, you earn 5%. How much money do you have to invest today in order to get $10,000 when you need it? So we plug it into the formula over here. So we have future value times 1 plus divided by 1 plus I to the n. If we use our financial calculator for this example, we are now calculating what are we calculating? We're now calculating the present value, right? So in our calculator, we would have 10,000 future value, 5 I by Y, and N is going to be 3, and we would now, instead of calculating the future value, we would calculate the present value. So let's set this problem up on the board so that, again, when you buy the calculator and you plug it in, you know what I'm doing over here. So for that problem over there that I just showed you on the slide, let's go back and show you how to do that simple problem. And we have $10,000 is the future value, or future value. Then we have, is it 5 I by Y, guys? What is the I by Y? 5. And now we are computing or solving for present value, right? And if you do that, it's going to give you whatever the answer was, 8,500 and something. So as you can see, well, yeah, those formulas are very easy. That's what you have to do. But this is how you would do it to, again, recheck your answers using the financial calculator. All right, so present value, future value, pretty easy. And remember again, at this point in time when we're discussing present value and future value, we are looking at a single cash flow, or what's known as a lump sum. Okay, so what are lump sums? Let's just review that very, very briefly. I have timelines over here. I'll open that, present value of an investment. And it shows you, well, let's say we want to know the present value of only one single cash flow. Timeline looks like this. If you want to know the future value of just one investment, let's say, the timeline looks like that. That's an unknown, and we don't know. I remember though, in reality, we deal with not one cash flow, but multiple cash flow. There are 3 different types of multiple cash flows that the book talks about, all right? The first one is an annuity, the second one is an uneven cash flow, and the third one is a perpetuity. So let's go back to our slides, and let's look at what we have over here. All right, but before we do that, let's look at a couple of other items. That is determining the discount rate given PB, FB, and T, and then determining N when we're given PB, I, and N. All right, so when we are trying to determine the discount rate, what is the discount rate, by the way? What is it? Well, in one case, if you're trying to calculate the present value, it's the rate at which the cash flows are being discounted at. If you're calculating the future value, it's the rate at which the cash flows are compounded at. So one thing you need to know about present value, future value is that, well, when you are trying to calculate the future value, you're always going to end up with a bigger number than what you started out with. Present value, conversely, it's going to be a smaller number. So determining discount rate, let's look at the formula. So this is the formula you use if you want to do it manually. All right, if you're using the calculator, what you do is you plug in present value, future value, and N, and then solve for I by Y. Okay, and finally, if you're solving for, let's say, N, this is the formula you have to use. But if you're using the calculator, again, you plug in PB, FB, I, solve for N. So again, these formulas are again just for lump sums. For annuities, they become even more time consuming. Again, again, for mortgages, or there are situations when we encounter what's known as non-annual compounding, or compounding that's non-annual, okay? What do we do in that case? What do we do if the compounding is non-annual? Let's say it's monthly. That's the easiest one to think about, the monthly compounding. So let's say you have a $100,000 house for 30 years, $100,000 house, 30 years, and 12% per annum, and maybe you're trying to calculate the payment or something like that. So again, $100,000 house, 30 years, 12%, I forgot to say, compounded monthly, let's say, compounded monthly. So when it says compounded monthly, that means it's not annual. You have to make some adjustments, okay? So what you need to do is divide R, or the rate of return, and multiply N by the compounding frequency. All right, for monthly compounding, what is the compounding frequency? How many months are there in a year? 12. So that's the compounding frequency. Okay? So it's again, to make your life easier, I've given you an easy example, 12%, 30 years. So we have to convert 12% into monthly, so that's going to be 1%, 12 by 12, 12% per year, 1% a month. 30 years, or 360 months. That's 30 times, so 30 years is nothing but 360 months. So you have to do some sort of a conversion. So the rule is, again, multiply the number of years, or N, and divide the rate by the compounding frequency. Compounding frequency, again, monthly 12, semi-annual 2, quarterly 4 quarters in a year, daily 360 or 365, so on and so forth. So the calculator does have an option, okay, I'll tell you. Calculator has an option where you can change the periods per year, okay? So let's say, what I have seen historically is once you change the period per year to, let's say, month or semi-annual, whatever, you forget to change it back. It happens all the time. And when that happens, you get all weird answers. So all your answers for annual problems come out to be weird, and you don't know what's going on. So that's why you do this manually, so that you don't have to encounter that difficulty when you forget to change it back, because you're not changing anything. All right, so how do we tackle non-annual compounding problems? It's pretty simple. All we have to do is do the adjustments and then do whatever we were doing, do our calculation. So how does a non-annual compounding problem look like? We'll do one example. What is the present value of $1,000 if the interest rate is 6% compounded monthly over 4 years? Okay. What if it is compounded semi-annually? So let's do this example on the board to make sure that we are. I'll do it using the calculator, and I'll use it using the formula, and let's see how that works out. Okay. All right. So A, let's write A. Compounded monthly is A, and B is compounded semi-annual. All right. So if we want to do it manually or using our formula, remember we have to make these adjustments. I'm going to erase these, if you don't mind. So manual, and this is going to be A. Present value of $1,000. What is the question asking for, guys? What is it asking for? What is it? Present value. Okay, so we don't know. That's the unknown. Okay. And what is given to us? All right, 1,000. What else? N is 4, right? And I by Y is 6. Or 6%. Okay. So when we do it manually, we have, it is monthly, right? Month. So this is going to remain the same, obviously. This is going to be multiplied by 12, 4 years or 48 months. And I by Y equals 6% divided by 12. Is it 0.05% or what is it? 6%? Alright. So when we calculate the PV, it is future value divided by 1 plus I to the n. Alright. Or future value is 1,000, 1.005 raised to the power 48. Alright, so this is using the formula. Now when we go to the calculator for monthly, we do 1,000 FV, 48N, and 0.05, not 0.005 because we're doing 6 divided by 12. Alright, 6 divided by 12 is 0.5, right? 6 divided by 12 is 0.5. 0.5 is your I by Y, and solve for compute present value. So remember the decimal thing in the calculator. When you're doing it using the financial calculator, it understands 66%. On the other hand, when you're doing it manually, you have to convert the 6% to a numeric number, which is 0.06, and then deal with it. So there is this difference. But as you can see, the ease of use with the calculator is like super easy, right? You just don't have to worry about anything. All right, we can do the one which is semi-annually as well. We just have to change N to 8, I by Y to 6 by 2 or 3%, and then everything else is as is. So again, don't worry too much. Again, we'll spend some time, but I'll assign you some problems, and please do work on them on Labor Day. I'm just kidding. Just work on them. Just spend, I don't know, half an hour, 1 hour before class or on Wednesday trying to solve them so that, again, my objective is to teach you and make sure that you're doing well and also be prepared for C25. All right. Let's look at time annuities, perpetuities, and uneven cash flows. And just to give you an idea, annuities look like this. Uneven cash flows look like that, and then perpetuities are never-ending stream of cash flow, stream of equal cash flows that never ends. So if you don't remember annuities are, just think of it as student loans, car loan payments, or mortgage payments. Okay, they're equal, and they occur at equal intervals in time. If you own a house, you probably pay, a monthly mortgage payment every month. Probably you have taken out an FRM or a fixed rate mortgage such that your monthly payments don't change over 30 years or 360 payments. So that's an example of an annuity, right? So annuity, equal payments that you make every month. Car loans, student loans, all other loan payments are also based on fixed rate, and they're also fixed rate, or they're also annuities. Again, equal payments, equal intervals in time. Then you have uneven cash flows. All right. So what are uneven cash flows? Again, they are cash flows that are not annuities, that are uneven. Okay, so an example is this. Let's say you have, you're saving money. You deposit $100 in year 1, 200 in year 2, year 3, and year 3 300. And what is your present value or future value of the cash flows? They're again cash flows that are not equal, that are unequal, and you encounter them several times in your lives as well. Finally, we have a perpetuity, again, a stream of cash flows that never end, and that's how this looks like. Okay, so I have forever. All right, let's real quick look at how do we calculate the present value and future value of annuities. And this is the compact formula, and I'll show you on the board where does this formula really come from. So we already talked about it. We said there are two formulas that are very, very important. That is the present value of a lump sum and the future value of a lump sum. But what about annuities and what about uneven cash flows? Let's just draw them so that you visually understand what's going on. Or I'm going to erase that again and draw some timelines for you. Two timelines actually. That's So you have a timeline that looks like this. Let's see. 5, 0, 1, 2, 3, 4, and 5. And let's say they're all equal amounts. C, 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 C. These are all the cash flows. All right, and let's call this an annuity. And then let's have another one. Fine. And let's call this an uneven cash flow. Uneven cash flow. C1, C2, C3, C4, C5. So again, the only difference is the cash flows are the same and the cash flows are not the same. So remember, if you want to find the present value, normal formula or the formula for a lump sum was future value 1 plus I to the n. Therefore, for the annuity, over there, because we have several different cash flows over there, it's going to be C 1 plus R plus C 1 plus R or I squared C 1 plus I to the n. All we are basically doing is adding all the cash flows, or adding all the future values, and then discounting them. As you can see, when we're discounting it, we have to raise it to the power 2 and 3 and 4 and 5, because again, it's over time. So for uneven cash flow, we have C1, 1 plus I, C2, 1 plus I squared, Cn, 1 plus I to the n. Again, we're assuming that the cash flows are different now, so we have C1, C2, C3, C4, and Cn. On the other end, for annuities, we're assuming the cash flows are all the same. We have all the C's there. Similarly, we can calculate the future value as well. So again, these are the formulas, and then when we rearrange the equation, do some algebraic manipulation, you have the formula that I have on the slide, but that's the formula, again, that's the basic formula. Future value now, future value, present value, 1 plus I to the n. So for the annuity, it's going to be C 1 plus I plus C 1 plus I squared, C 1 plus I to the n. And for the uneven cash flow, C1 1 plus I, C2 1 plus I squared, Cn 1 plus I to the n. So this is, again, if you want to do it manually, or trying to find the present value or future value of uneven cash flows or annuities, that's what you basically have to do. And that's the reason why I'm telling you, go for the, right? All right, let's go back and let's look at some problems. Again, You have, this is the compact formula for present value of an annuity. But again, for the present value of uneven cash flows, you have to do it iteratively, one at a time. Not a big deal if you're studying online and you have a lot of time at your disposal, but for you guys who have not a whole lot of time, it's kind of difficult. All right. Let's look at this example over here. We have one thing that you have in your calculator, the financial calculator, is the payment button. And just remember, the payment button is for the annuity. Okay? The payment button is the annuity button. And whenever we are dealing with annuities, you will be using the payment button. So if you look at this Texas BA2 Plus handout that I gave you, all right, I'll ask you to look at example 1, all right, which is on page 3. So we have example 1 on page 3, example 2 on page 3. Then I have example 3 on page 4, example 1 on page 5, which is an example of an annuity. Just look at page number 5 and example number 1, which says ordinary annuities. Can you see that? And it says, what is the future value of an annuity of $100 paid at the end of each year for 5 years? Interest rate is 6%. Okay? So we have 5 is N, 6 is I by Y. You don't have to worry about PV. And payment is 100. One other thing I want to talk to you about the calculator. So there's a plus minus sign. And let's say in this example you didn't put that plus minus sign. The answer you would get was negative 563.71. And obviously you know that, well, if I invest $100, there's no way I'm going to lose money at 10% or whatever. So you just ignore that negative sign, okay? So either you plug in negative or you ignore the negative sign altogether. But again, as I was telling you, the payment button tells the calculator that the payment is occurring every year, every quarter, every month, whatever it is. Okay? All right. So we have an example over here. It says a 90-year-old wins the lottery, a sum of $9.3 million. However, she will not receive the cash up front, but only receive $465,000 for the next 20 years. How much should she be willing to accept now if the discount rate is 8%? So let's think about this example and let's see what is the question really trying to ask for us. We should be able to see that this is an annuity problem. Why? You have to tell me. But what do we solve in this example? What are we solving for? All right, we're solving for the present value. Very good. But what is given to us though?
The cash flow.
What are the cash flows? How much are they? You're right.
465,000.
Okay. Very good, very good. So if you think about it, 465 times 20 is about $9.3 million. Okay, so 9.3 million is not that relevant in the problem, other than it's 465 over 20 years. So let's draw the timeline and see how the timeline looks like. I'll use this part of the board again because it's being taped. Alright, so the timeline looks something like that. And your peer already identified that the $465,000 was the payment. Is absolutely correct. So we're looking for the present value. So this is 1, 2, 3, 4, 5, all the way to 20. And we have 465K all the way for 20 years. We want to know, well, should she agree with that, or should she agree to some amount of money over here? So we're trying to calculate the present value, right? If we want to use if we want to do it manually, we will be using the annuity formula, present value of annuity formula, and using those as the payment, okay? But if you're using the calculator, we'll do this. 465,000 payment, 20N. What is the I by Y, guys? Do you remember? Is it there somewhere?
8%.
8 I by Y, and compute present value. Okay, so that's going to give us a present value Let me see how many millions of dollars that is. Does anybody have the notes open? Is it 5 point something dollars or? All right, it's about $4.56 million. And what does $4.56 million really mean? It just means that, well, if somebody offers her more than 4.56, she should be willing to go with the deal. If somebody offers her less than 4.56, she should say no. So 4.5 meaning, again, that's kind of her threshold at 8%. If somebody gives her $5 million, she should be like, yes. If somebody gives her $4 million or anything less than 4.56, she should say, well, I would rather have the 20-year cash flows until I'm 110 years rather than having the $4.5 million out. I mean, it shows, well, manually, how would you calculate the future value of an annuity? How does it look like? Well, this is an annuity, $2,000 each, 4 years at 5%. So it's just basically showing you, calculate each one of them and add them together. If we were using our calculator, we would have 2,000 as the payments again, I as 5, N as 4, and we would calculate future value. Present value of an annuity, we had, again, payment would be that, I would be 5, N would be 4, and we would compute the present value. But again, next week when we all have the calculator, we'll